So a chemical equation is a representation of a chemical reaction or a chemical change. On the left of the chemical equation, you have your reactants, which are the substances that, as the name implies, do the reacting. And on the right, you have your products, which again, as the name implies, are the things that are produced in this chemical reaction. So if we were to think about this chemical reaction that we have drawn, we have copper reacting with oxygen to make copper 2 oxide. If we were to count the atoms on each side, and count our coppers, we'll count our oxygens. On the left, we have a single copper, and on the right, we have a single copper. On the left, because this 2 underneath the oxygen, you actually have 2 oxygens, and on the right, there's only 1 oxygen. So with how this chemical equation stands right now, it appears that one of the oxygens is lost in this chemical process. Now, the law of conservation of matter, says this can't happen. In a chemical reaction, atoms are neither created nor destroyed. So we have to account for this lost oxygen somewhere. So we do that by balancing chemical equations, and the only way to balance a chemical equation is by the use of coefficients. Since on the right, we need there to be 2 oxygens, you cannot come down here in the bottom and just put a subscript of a 2. By doing that, you have changed the substance from CuO to CuO2, which is a different chemical substance and probably doesn't even exist if I had to guess, but you have altered the chemical properties or the chemical composition of that, and you can't do that when you're trying to balance a chemical equation. Instead of putting subscripts, so we can only balance this by the use of coefficients. So out front, if we put a 2 in front of this copper 2 oxide, that will give us 2 sets of CuO. In 2 sets of CuO, there are a total of 2 coppers and a total of 2 oxygens. That takes care of our oxygens being balanced, but now on the copper side, we need to balance it as well. So since we need 2 coppers on the left, we'll put a coefficient of 2 in front of copper, meaning we now have 2 copper atoms, and you'll notice everything is balanced. On the left, we have a total of 2 copper atoms and an O2 molecule, which is made up of 2 oxygens. And on the right, we have 2 different CuOs, which means 2 coppers went in, 2 coppers came out, 2 oxygens went in, 2 oxygens came out. Simply the only thing that has changed is their arrangement. Now, it is possible that you could balance this chemical equation another way. Forgive me while I erase. On the left, you have 1 copper. On the right, you have 1 copper. On the left, you have 2 oxygens. On the right, you only have 1. So it is possible that you could put a fractional coefficient in front of this oxygen, because this means half of an O2. Half of an O2 is 1 oxygen, which is what we need over here. The only stipulation here is that you can't have half an atom in a reaction, or half of a molecule rather. So whenever you use fractional coefficients, you are more referring to moles instead of individual atoms. So in this case, we would mean 1 mole of copper reacts with half a mole of O2 to produce 1 mole of CuO. Okay, so in this next equation, you'll have to forgive me, I ran out of room on the right side, but we have 2 sodiums on the left and only 1 sodium on the right, 1 copper, let's write this down, 2 sodiums on the left, 1 on the right, 1 carbon on the left and 1 carbon on the right, 3 oxygens on the left and 3 oxygens on the right, because there's 2 here and 1 here, and 1 iodine on the left and 1 iodine on the right, and still yet 1 hydrogen on the left and 2 hydrogens on the right. Now there's only a couple things messed up here, the sodiums and the hydrogens. Let's just try to fix one. And I'll just start with the sodium. In order to make there be 2 sodiums on the right, I have to put a coefficient of 2 out front of the sodium, iodide. That will give me 2 sodiums, but that also gives me a total of 2 iodines. And my favorite technique of solving chemical equations is, as you try to fix one thing, if you mess something else up, address what you just messed up. So before I put that 2, our iodines were balanced, but now they're not. On the right, there are 2 iodines. So I'll come over to the left and make there be 2 iodines as well. And I have to do that with a fraction or with a coefficient out front of the HI. Sorry, to be honest, I had to pause my video and I'm not sure where I was. I know I'd put a 2 on the HI though. So it's going to give me 2 H's on the left and 2 I's on the right. And by almost magic, everything is now balanced. All right, so we've got one more. C4H8 plus O2 yields CO2 and water. Now my advice here in a situation like this, since oxygen appears in multiple things, I would leave it for last. Also, another reason to leave oxygen for last is if you have an element by itself, such as O2 or just like copper, something by itself, I'm going to recommend you save those for last. So let's just address the carbons first. You have 4 carbons on the right. In order to make there be 4 on the, I said on the right, 4 carbons on the left. In order to have 4 on the right, we've got to put a 4 here. That'll give us 4. Now we can address the hydrogens. On the left, there are 8 hydrogens. So on the right, since they're coming in sets of 2, you'll need 4 sets of 2. That gives you 8. On the left, you have 2 oxygens. On the right, you have 4 groups of 2, so that's 8, plus 4 groups of 1, which is 4 more. So it's a total of 12. So in order to make there be 12 on the other side, you would need to put a coefficient of 6 out front of the oxygen. That makes all of our atoms balance out. No matter was lost in this reaction, so you know you're correct.